Okay, in this video, we have a model of a mass which is attached to a spring, and that spring is attached to the wall. So this is a model of mechanical vibration. And the mass vibrates horizontally on a smooth surface. So we're imagining that there's minimal friction, also called damping. So there's minimal friction. And its equation of motion is given by x of t equals 8 sine t. T is time in seconds and x is in centimeters. And x is the displacement from an equilibrium position. So x can be positive when the mass is to the left of equilibrium, in which case the spring wants to pull that mass back towards the wall. But when the mass gets pulled back towards the wall, then the mass is to the left of the equilibrium, and then x will be negative, and the spring will want to push the mass away from the wall. Now, to find the velocity, we're just going to use the fact that velocity is derivative of position. And so in this case, we get v of t is equal to x prime of t. And let me highlight what x of t is. X of t is 8 sine t. So we take the derivative of x of t, and that makes x cosine t. Then that gives us one answer. We're trying to find the velocity function. The other piece that we're looking for is that acceleration is equal to the derivative of velocity. And so we have a of t equals v prime of t. And now I look above here. Well, v of t is 8 cosine t. And so the derivative is negative 8 sine t, because the derivative of cosine t is negative sine t. All right, so we did that one. Find the position, velocity, and acceleration of the mass at time t equals 2/3 pi. In what direction is it moving at that time? And that's all for that problem. Okay, so let's check that out. All right, so position is going to be, should I write it down? I guess I will. Position, I'll write down the word position. Position is x of 2 pi over 3. I need to work on making that just a little bit more neat. X of 2 pi over 3, and that apparently is equal to 8 sine 2/3 pi. Well, let's check that out. Well, the reference angle for 2/3 pi will be pi over 3. I'm going to use the unit circle here. That's what I will use to get this solved. Well, this is turning to be, oh, all right, there we go. Okay, so here I have 1, 0 in the unit circle, 0, 1, and my reference angle is pi over 3. So I have that over here. Now, when I look at that pi over 3, then that'll give 2/3 pi in this position, because pi, which is 3/3 pi, minus pi over 3 makes 2/3 pi. I see that the magnitude of the x-coordinate is less than the magnitude of the y-coordinate. So I'm going to write 1/2 for the x-coordinate, or the first coordinate, I should say, and rad 3 over 2 for the second coordinate. And that's how I'm going to get that. You can also start fiddling around with the reference triangle being, and with the angle corresponding to pi over 3 is 60 degrees, and you can fill out that right triangle. So that tells us the cosine is adjacent over hypotenuse 1/2, and then I write 1/2 up there. Alrighty, so let's see. Sine is the y-coordinate, so it's going to give square root of 3 over 2, and that makes 4 rad 3. And that is in what units? It says centimeters. Okay, now moving on to, that's one answer. Then I'll move on to velocity. And I'll have v of 2/3 pi, which is equal to 8 cosine 2/3 pi. And that gives 8 times negative 1/2, because on the unit circle at 2/3 pi, the first coordinate is cosine, and that first coordinate is negative 1/2. And so therefore I'm going to have negative 4 centimeters per second. Now on this our model here, the positive direction is moving towards the right. So when x is, so to the right is the positive direction, to the left is the negative direction, just like what we always have with the number line, horizontal number line. All right, and then acceleration. We have a of t, a of 2/3 pi, is equal to negative 8, looking above here. Acceleration is negative 8 sine t, but I'll have negative 8 sine 2/3 pi, and that's the y-coordinate at that point, 2/3 pi. So I plug that in there, and I get negative 4 rad 3 centimeters per second squared. Now, in what direction is it moving at that time? Well, at t equals 2/3 pi. By the way, pi is around 3, so 2/3 pi is around 2/3 times 3, which is around 2. So it's around 2 seconds. At 2/3 pi, the velocity is negative. And whether velocity is positive or negative, in other words, the sign of the velocity, is going to determine whether, is going to tell us whether it's moving to the right or the left. So the velocity is negative at 2/3 pi, therefore, is it? Double check. The velocity is negative 4 centimeters per second. Therefore, the mass is moving to the left, because why? Because the left is the negative direction. Notice that the position is positive, so that means that the mass is to the right of the equilibrium, because the position is positive. But the velocity is negative, which means the mass is moving to the left. And the acceleration is negative, which means it's accelerating to the left. So that's, maybe I'll highlight that also down here as our answer. And I believe that's all we have here. Okay, well, that finishes that video. Thank you. Goodbye.